Alright, ladies and gentlemen, in today's video we're looking at section 11.2 on arithmetic sequences. One of the two most common types of sequences we use in mathematics is the arithmetic sequence. The other is the geometric sequence, which we'll be talking about in section 11.3. So let's start with a definition. An arithmetic sequence is such that any two consecutive terms share a common difference, which we denote D. In other words, it looks like this. The sequence is arithmetic if you have the first term and then the second term is simply the first term plus that common difference. You add another D to this, getting 2 D's to get the next term, add another D to this. So there's 3 D's to get the next term, and so on and so forth. Okay? The recursive definition can be used. So the recursive version of an arithmetic sequence is of the form a sub n is a sub n minus 1 plus d for the recurrence relation. Meaning a sub 1, of course, can be anything. It doesn't matter. It's the recurrence relation that defines the arithmetic form for this. Okay. All right. So let's take a look at a couple of examples from the exercises. In problem 6, you're given the sequence 5, 11, 17, 23, 29, and you're asked to find the common difference. Well, all you have to do for an arithmetic sequence is take any term minus its prior term. 11 minus 5, you get the common difference. 23 minus 17 would have worked. 29 minus 23 would have worked. 17 minus 11 would have worked. As long as there are 2 consecutive terms that you do the subtraction for, that gives you the common difference in the problem. Okay, let's take a look at number 10. Write the first 5 terms, where you're given the first term is negative 25 and the common difference is negative 9. So how do we do this? Well, the second term is the first term plus the common difference. So that's negative 25 plus a negative 9 is a negative 34. Okay, so first term, second term. Third term is the second term plus the common difference. So that's a negative 34 plus a negative 9 is a negative 43. The fourth term is the third term plus the common difference. So negative 43 plus the negative 9 is negative 52. And the fifth term is the fourth term plus the common difference. So negative 52 plus a negative 9 is negative 61. And those are the 5 terms of the sequence. Okay. All right, let's take a look at number 12. They tell us that a sub 1 is 17 and that a sub 7 is negative 31. And they want the first 5 terms of this sequence. Okay? So what I would suggest we could do here is actually figure out the generating function for this. You know that a sub n is a sub n minus 1 plus d, right? And you know that a sub 1 is 17, and a sub 7 is negative 31. In other words, a sub 7 is a sub 6 plus d, right? But we also know this, that a sub n for any arithmetic sequence is the very first term and then you have to add the common difference n minus 1 times to get to a sub n. Right? A sub 1 is the first. You add a d, you get a sub 2. You add another d, you get a sub 3. You have to do that n minus 1 times to get to a sub n. So this a sub 7 is a sub 1 plus 7 minus 1 times d. And we know that value is negative 31. We know the a sub 1 is 17. 17 plus 6d is negative 31. Subtract 17 from both sides. Negative 31 minus 17 is negative 48. Divide by 6. You've got d is negative 8. Now, once you have the d, now you can write down the first 5 terms of the sequence. A sub 1 is 17. A sub 2 is 17 minus an 8 is 11. A sub 3 is 11 minus 8 is 3. A sub 4 is 3 minus 8 is negative 5. A sub 5 is negative 5 minus 8, or negative 13. There's your sequence. First 5 terms. Okay? All right, let's take a look at problem number 16 next. We want to write down the first 5 terms. No, the first term is 5, sorry. A sub 1 is 5. The common difference is 6. Find a sub 8. Well, again, a sub n is a sub 1 plus n minus 1 times d. So a sub 8 is a sub 1 plus 8 minus 1 times d. That is 5 plus 7 times the d of 6. 7 times 6 plus 5 is all you have to do to get this figured out. Was it 5 or 8? Read the question again. 16. Yeah, find the 8th term. So 7 times 6 is 42, plus 5, 47. There's the 8th term. Let's try number 22. In 22, here say, find the first term given 2 terms from the arithmetic sequence. And the 2 terms you're given. Again, you want to find the first term given that a sub 9 is 54 and a sub 17 is 102. And so again, we're going to rely on the fact that we know this is the form for the generating function for any arithmetic sequence. So a sub 9 is a1, which I don't know, of course, plus 9 minus 1 times a common difference that I also don't know. Okay, and we know that that is equal to 54. And a sub 17 we know is a1 plus 17 minus 1 times the unknown common difference is equal to 102. So in other words, you have a1 plus 8d is 54, and a1 plus 16d is 102. Now, if we do a subtracting here, a1 minus a1, those will cancel. 8d minus 16d is a negative 8d, and 54 minus 102 is going to be a negative 48, I believe. Oh, and of course 8 minus 16 is 8, right? So what do we get here for d? 6. Now, once you know the d, then you can go back over here and find the a1. Remember, a sub 9 is 54. Was a1 plus 9 times 1 is 8 times the d, which is 6. Okay? 54 is a1 plus 48. Okay, subtract 48 from both sides, and you get a1 is 6. And you're done. You found a1. Okay. Let's take a look at problem number 26 next. They want us to use the recursive formula to write the first 5 terms. And what they give us is that the starting value, a1 is 39, and a sub n is the previous term, minus 3. So a sub 2 is a1 minus 3. 39 minus 3 is 36. Those are the first two terms. A sub 3 is a sub 2 minus 3. 36 minus 3 is 33. There's the third term. A sub 4, a sub 3 minus 3. 33 minus 3 is 30. There's the fourth term. And a sub 5 is a sub 4 minus 3. 30 minus 3 is 27. There's the fifth term. Okay? All right. Now, let's take a look at problem number 40, where they give us the start of an arithmetic sequence, 2, 6, 10, dot, dot, dot. And they say, write a recursive formula, and then find the 12th term. Well, what would the recursive formula be here? A sub 1 is simply the first. And now how much do I add each time? I simply add 4. So a sub n is the previous term plus 4. There's the common difference. Okay, there's the recursive definition. Now you could go through the recursive definition all the way up to a sub 12 as they want, or you could do the following. You could say, once I know the common difference and I know a1, why don't I just write this, the generating function. That is 2 plus n minus 1 times 4. And you can, of course, simplify this, can't you? 4 times n is 4n. Negative 1 times 4 is a negative 4 plus 2 is a negative 2. There's a simple formula for a sub n. So a sub 12 is now 4 times 12 minus 2, or 46. And you've got it. Let's do another example, number 48. Write an explicit formula for this sequence where you have given negative 18.1, then negative 16.2, then negative 14.3, and so on. And so what I see is I'm subtracting, or I'm going increasing in value, actually, right? These are negatives, so they're increasing in value by a common difference of 1.9. Add 1.9 here to get this, add 1.9 here to get this, and so on. So there's our common difference. We want to write an explicit formula. Well, we also know that a1, the very first term, is negative 18.1, and we know that a sub n is the first term plus n minus 1 times the common difference. So that's negative 18.1 plus n minus 1 times 1.9. Negative 1.9 and negative 18.1 make negative 20. And there you go. There's your explicit formula. Let's try one last problem, and we'll wrap up this short section. 54. Find the number of terms in the sequence. This actually turns out to be surprisingly useful to be able to do in calculus class. How many terms are there in this arithmetic sequence? Well, a sub 1 is 1.2, and the common difference is clearly seen to be 0.2 is how much we're adding each time. So the generating function for this is 1.2 plus n minus 1 times 0.2. Minus 1 times 0.2 is a negative 0.2. Add it there. And there is a simple form for the generating function. And so you want to know how many terms this goes to. Simply take the last term and set it equal to this and solve for n. Subtract 1. Divide by 0.2. There are 14 terms in this sequence. There are 14 terms here. And that's how you do it. Okay? As always, if you have any questions or concerns, don't hesitate to contact me. I'm always happy to try to help.